Welcome back, everyone. We now begin session 2 of day 3. It's my honor to introduce our next speaker for the day, Dr. Krishna Kumar Muthuswamy. Sir, am I audible, sir?
Yeah, I can hear you.
Yeah,
This is
thank you, sir. Thank you, sir, for your response.
sure.
He is a principal engineer and manager at Qualcomm, recently in Santa Clara, USA, with more than 20 years of deep experience in wireless, local area network software development, and next generation Wi-Fi technology. He holds a master degree in computer science and engineering from Government College of Technology, Coimbatore, India. He began his career as a Wi-Fi software engineer at Athros, India, before transitioning into senior technical leadership and execution roles at Qualcomm, US. Chris has led the design, development, and delivery of multiple acting as Wi-Fi host driver and application solutions spanning 802.11ab protocols. His expertise cover various 802.11 protocol design, architecture, development, debugging, and validation. He has played key technical leadership roles in pioneering 11AC, 11AX, 6 GHz, and 11BE compliance driver commercialization, successful Wi-Fi certification, and customer enablement. Known for his technical ability to guide cross-functional terms across geographies, Chris has consistently driven major Wi-Fi certification milestones, performance optimizations, and complex feature rollouts. His contribution has earned several Qualstar Awards, recognizing impactful innovations, strategic problem solving, and successful commercialization of advanced Wi-Fi technologies. He will be speaking on Wi-Fi 7 technology. As we know, Wi-Fi 7 is the next revolution in wireless connectivity, enabling ultra high throughput, low latency, and intelligent multi-link operation for 6G ready devices. Sir, we are delighted to have you with us. I now invite Mr. Krishna Kumar Muthuswamy to take over this session. Sir, you can proceed, sir.
Thank you, Rahul. Um, um, Good evening, everyone. Let me share my slides. I think
Very good evening, sir.
it's morning for here. So I am from the Bay Area. So it's a 6 a.m. in the
Yes,
morning.
sir.
Okay, I think thanks for this great opportunity. I to my friend Jay Singh, Dr. Jay Singh. He has requested me to give a session on the Wi-Fi technology, and it's my pleasure to share my experience on the Wi-Fi evolution. You able to see my screen?
Yes, sir. Yes, sir. It's clear. It's visible, sir. You can proceed.
Yeah. You are seeing the main screen or your split screen?
First slide of the screen, sir. Not the
Okay,
only
you are seeing
slides,
the
sir.
full screen, right?
Yes,
Okay,
sir. Yes, sir.
okay, fantastic. Let me go to the um agenda of this kind of session. So I'll be covering the some of the fundamental technology evolution behind Wi-Fi 7 and kind of share some of the very high level um, kind of advancement in Wi-Fi 7 and yeah, at any part of the meeting. If you have any questions, feel free to kind of raise your questions in chat or the session. So before going to the Wi-Fi 7 technology, right? So I want to give some background slide. So evolution of Wi-Fi in kind of last 10 years, right, has been growing for various demands of applications. Mainly, we have online gaming, cloud gaming, virtual reality, cloud kind of experience, very demanding enterprise networking, right? Metaverse, reality, AR, XR, right? For all these kind of applications, Wi-Fi has been a major player, right, to meet all its demands, right? Um, so we have so much of Wi-Fi kind of MAC and PHY level requirements to meet these use cases. So Wi-Fi is kind of like Ethernet, right? So they have the Ethernet level expectations. Though the physical medium is .11, but the user experience, right? So they have pretty high expectations like Ethernet, right? Extreme speeds, extreme throughput capacity, a very low latency to kind of feel the experience for virtual reality, cloud gaming, metaverse, AR, XR. In short, the expectation is like, hey, Wi-Fi has to be uh, meeting all the demands as if that we are in the wired link. So that is the core reality of the Wi-Fi evolution. Okay, so over the years, okay, the experiences are building higher. Probably the next slide will give you another level of kind of visibility, right? So kind of to cover what is Wi-Fi 4, what is Wi-Fi 5, what is Wi-Fi 6, and what is Wi-Fi 7, right? So if you look at this chart, right? So we kind of started this Wi-Fi in 2003, right? Purely on the 11G kind of based medium access. It's like simple low FDM. The bandwidth is 20 megahertz, 2.4 gig spectrum, right? It's like just 1x1 or 2x2. Just 1x1 device, one stream device. Whereas like every 5 years, right, the Wi-Fi is kind of evolving. Right, in 2007, the 11N technology kind of emerged. Right, it's like a 4-stream multi MIMO technology. Right, the channel bandwidth is increased from 20 to 40. Right, it kind of expands to 5G spectrum. Right, it has aggregation. It has advanced high throughput medium access control. Right, so that is 11N. So every like 4-5 years, the demands of the user applications or the technology is increasing. So like Wi-Fi is also evolving, right? Or I don't know. So Wi-Fi is setting up the trend to kind of build new applications for the user to experience, right? In 2013, we have 8-stream multi-user MIMO. The bandwidth has increased from 40 to 80. So we have this 256 QAM coding and encoding technique, right? Higher throughput of MAC aggregation, right? It increased instead of HT, it's like increased from very high throughput medium access control. Okay, so Wi-Fi 5 has something called Wave 1 and Wave 2, right? So both are still AC, but the Wave 2 brings in another interesting feature where it's kind of a multi-user at the same time, at a single physical transmission. So we can kind of send it to multiple users, right? and using the OFDMA technology or MIMO technology. Okay. So 160 megahertz channel bandwidth. Okay. In 2018-19, so AX emerged, where we kind of introduced the 6G spectrum, basically, right? It's also based on OFDMA, but the only thing is it expands to 6 gig spectrum. It has scheduled access mechanism. It uses 1K QAM. From 256, they have increased to advanced coding, encoding, decoding technique, and they have introduced uplink mu kind of transfer at a single kind of instance. We can trigger multiple clients and get the uplink at a single kind of instance, right? And target wake up time and spatial reuse. So these are some of the advanced techniques in Wi-Fi 6, right? So as and when we evolve, right? So the demands of the applications that is evolving is also higher. So Wi-Fi 7 is trying to meet even more advanced stringent requirements, right? Spec is allowing 16 users at the same time. That means like 16 chains, 16 streams, and there is something called multi-link operation, right? So simultaneously it can transmit to multiple links for a single client. So far we kind of talked about just one link, one physical link, but Wi-Fi has introduced multi-link operation, right? The bandwidth is also drastically increased from 160 to 320 to kind of serve high throughput. So they introduced puncturing. These are interesting topics I will be covering up the upcoming slides. 4K QAM, right? So they kind of increased from 1024 to 4K QAM. And there is another concept called multi-RU. So instead of just single resource unit, now we can pack multiple resource units to a single client. So that's the way like Wi-Fi 7 has evolved, and we'll be getting into some more details of this. Right. So I'll give another perspective of all this Wi-Fi 4, Wi-Fi 5, Wi-Fi 6, Wi-Fi 7 technology, right? With respect to throughput, latency, and manageability. Okay. So during the Wi-Fi 4, right? So it is evolved from the throughput point of view. It's evolved from 2 to 54 Mbps, and in 11N like increased to 600 Mbps. Okay, and during AC it has increased to 6.8 Gbps. In AX 9.6 Gbps, and in 11B, right? So which is like at close to, if you have 16 streams, it can achieve up to 46 Gbps speed. Okay. From the latency perspective, right? I think maybe even I would say, right, even till pre-Wi-Fi, there is not much focus on latency. They don't care about the user experience. They just purely care about the throughput and the speed. That's it, right? They don't care about per packet latency. The per packet latency is like pretty high. It does not solve certain like use cases like uh, VR, AR, other use cases, right? So that needs high kind of low latency time, right? So basically, per packet latency is pretty high, long tail latency for AC. Slowly after AC, right, AX kind of reduced this kind of tail latency is reduced, and 11B is still helping to minimize this latency. This is where it's able to meet all the applications that we have seen in the previous slide, right? So another dimension to look at is, so far from the access point side, right? So from the access point side, okay, we kind of look at from purely unmanaged network, right? So the access point doesn't think about, hey, how to manage the clients better, how to provision the clients better. But slowly, in 6 and 7, basically, the concept of managed network comes in. Okay. Any questions? If not, I will go to the next slide. Yeah.
No question, sir. You can proceed.
Okay. Yeah, before going into the details of um, Wi-Fi 7 technology, right? So I just want to give a perspective of some high-level comparison. How does it look like? A very abstract. Okay, let's take this simple network where we have access point, we have different clients, like which is like a AR, like a VR kind of a glass, as a laptop. There is a mobile phone. There is like a monitor, right? So all are connected to the access point, right? But they are interlinked, right? So if you look at the color, right? So they are a lot of overlapping traffic, so which are looking for channel access opportunities. Okay, so that means that you have to manage it well and meet all the demands of all these applications, right? Recent emerging applications. So one of the core kind of idea is it brings higher speed. If you look at Wi-Fi 7, Wi-Fi 6, right? Over the time, always with the latest evolution in Wi-Fi, right? The data is higher over time. So because of the 4K QAM, because of the MLO, because of the um, multiple resource units and puncturing, right? And high kind of 11BE rates, right? So all this kind of combine to kind of give this higher throughput, right? So even in a very congested environment, right? So even in kind of hundreds of clients, so we will be able to meet the demands of all these applications. So that's what, okay. So the Wi-Fi 7 is able to achieve faster connections, right? And higher throughput, even in the less congested or higher congested or less congested network. So this is another dimension to look at how Wi-Fi 7 is kind of achieving throughput, yeah, better than Wi-Fi 6. This is one angle. Let me go to another slide. Okay. With respect to latency, right? So we talked about the throughput, right? So if you look at these packets in this network, right, we have multiple clients. So certain client, right, which is like a Meta Glass or some kind of AR, VR devices, right? That needs very low latency. The gap between that each and every packet is expected to be very low, so that you feel the experience. You don't get stuck, right? So you see a long latency, right? So if you look at the Wi-Fi 6 or pre-Wi-Fi 6, the latency is pretty long, right? And what is the impact of it? It has long delays in the calls, like video calls or voice calls, right? It's long delays. So it got stuck. The game is kind of hang in the middle of the game, right? So when you use this AR, VR, right? So basically you get some kind of a headache or nausea because of the experiences creating a different effect to the human mind. So that is another dimension, right? So we have to look at, and Wi-Fi 7 eventually helps to reduce this latency into pretty small, so that per packet delay to look like hundreds of clients in the BSS, right? So is reduced. So this is one of the key requirement that Wi-Fi 7 is helping with. Yeah, any questions? If not, I will go to the next slide. So Wi-Fi 7 brings conventional improvements and innovative enhancements. Okay, so faster connection. So what does that mean, right? It has a pretty big fat pipe. so far till Wi-Fi 6, we have seen only 160 megahertz channel bandwidth. But Wi-Fi 7 brings 320 megahertz, right? And an option of 240 when we use puncturing. And we have 4K QAM, okay, where we can pack so much of data when the link is pretty high. The kind of a link or the medium is like very close and RSI is pretty high. Okay. So during very kind of a congested or some medium kind of busy situations, right? We have a concept called puncturing. Basically, we have the whole 320 minutes bandwidth, but pre-Wi-Fi 7, if some of the secondary 40 or secondary 80 or secondary 160 is all busy due to nearby interferences, right? So we will be reduced to very minimal bandwidth. But with puncturing, we can puncture which all subbands are congested and just use the remaining bandwidth so that you can still effectively use the whole kind of 320 megahertz bandwidth. That is an interesting kind of feature in Wi-Fi 7 that helps to kind of utilize the bandwidth pretty efficiently. Okay, so there is another concept called multi-RU OFDMA, right, which is called multi-resource units OFDMA, where we can pack multiple resource units for a single user. Whereas in pre-Wi-Fi 7, so it limits that, hey, we have to pack only one user or one RU in that particular OFDMA. So it imposes a strong restriction that we cannot pack multiple RUs. So kind of in a pretty big spectrum. So basically OFDMA helps to split into multiple RUs at even at a low of 2 megahertz kind of a channel spectrum. So this is another interesting feature that has been brought into Wi-Fi 7, right? So third interesting angle is like multiple connections established to the between the access point and the client. So we have this multiple links, though the connection is single, they have multiple paths to transfer the data. So we can have simultaneous transmission, simultaneous reception, just not with one link, with more than one link. We can go up to 16 links if possible, if clients and access points support that. So alternating multi-link is something like whichever is pretty kind of quick, right? Some link may be busy, some link may be quick, so that we can meet the latency. So the key point of throughput as well as latency is try to achieve in this multi-link kind of a connection. Any question on this? This is the core idea behind Wi-Fi 7, core technology behind Wi-Fi 7. No questions. Yeah, I'll kind of move to the next one. Okay, so I talked about adaptive interference puncturing, right? Basically, the same thing that I want to give with the example. Okay, let's say this is the whole bandwidth. Okay, so this is the primary 160 and this is the secondary 160. Okay, where in the Wi-Fi 6, okay, or probably this is 80 and this is 80. Maybe the channel is 160, for example. So in pre-Wi-Fi, if this particular subband is congested and it is like huge interference, you cannot use this one. Totally, this is wasted. The secondary 80 is wasted. Whereas in Wi-Fi 7, we can detect that and we can puncture this and effectively use the whole 160 or 320 megahertz bandwidth. This is one of the very efficient way of utilizing the medium. Whereas pre-Wi-Fi 7 doesn't have this support, right? So I talked about multi-resource unit, right? So this is a zoomed version of multi-resource unit. So basically, we have multiple clients connected, right? So AP will split that channel into multiple resource units. Let's say we have probably the each like one is 20 megahertz resource unit, 1, 2, 3, 4, 5, 6, based on you have like if it is 320, we have like 16. If it is 160, you have 8 20 megahertz subbands, right? All these individual subbands are packed with different users. So Wi-Fi 7 introduced that, hey, I can pack multiple resource unit for the same client. If you look at this particular color code, right? So 50 to 26 tone MRUs are packed for a single client, which need high demanding traffic, right? And also it can parallelly serve other clients at the same time. So this is another interesting feature where we can have an effective scheduling to manage a large set of users and still meet all the latency and throughput requirements. Okay, just a different perspective to look at. Okay, so now let's move on to the kind of a multi-link feature. Okay, so look at this. So traditional connection between the access point and the client is just always a single link. Okay, so what does it mean? So whenever a client discovers and connects, right, it goes to one band and it discovers the AP, it connects just with the one link, right? If the link is bad, right, it doesn't have a way to kind of move the connection to the other band, right? It has to disconnect it from the current band, it has to go to the other band, then it has to connect. Or AP has to do a kick out and kind of block the connection and should allow the connection in the other band. So basically, always it is a single connection. But Wi-Fi 7 brings multiple channel connections. So what does that mean? So they have a single radio. If you look at the client device, they have a single PHY, there's a single MAC, and they have a layer. But they are associated with two channels at a single association. Okay, when I do association, I always do connection with channel 1 and connection with channel 2, but still it's a single connection. It's called a MLO association, multi-link operation association. So why it is single radio? It will switch, okay, like to adopt the network congestion. For example, let's say 2 gig is really bad due to other traffic, okay. It will send a power save notification to the 2 gig and it will move to the 5 gig. Maybe let's say channel 1 is 5 gig, channel 2 is 2 gig. It switches whichever link it wants to go to. It's totally in the control of the client, basically, right? But still effectively utilize the medium. It doesn't stuck with one channel and stay for it, right? To meet all these demanding requirements of throughput and latency, right? So still single radio, single MAC, but it intelligently switches between two channels, right? But always active one at a time, right? Maybe there should be a logic to switch when to move to which channel. It's totally in the client's control, right? So this will help to adapt the network congestion, or the client has some other traffic to kind of like a hotspot or something, right? So it wants to use a specific band for hotspot operation, right? So this may be an interesting kind of technology to adopt with. Any question? Okay, let me go to the next one, alternating multi-link feature. Okay, so we have a single radio that can listen to two channels and transmit receive on first one available. Okay, it doesn't have MAC doesn't have the complete file
interference
on 2 channels. Hello.
when many devices are connected with a multiple.
Your voice is not audible. Yeah. Can you go ahead again?
Sir, not audible, sir.
Can you hear me?
Yes, sir. Yes, sir. Right now. Okay.
Do you have any question? Can I continue? Any question?
There is one more question. How multiple synchronization maintain?
Sorry, your question is still not clear to me. Can you be a little audible? You are breaking in the middle.
Sir, in the chat box from the participant, there is one question. In 5G technology, how to reduce latency in edge techniques? Yeah, what is the role of hopping?
In 5G or probably in Wi-Fi?
In 5G technology, sir.
Oh, I am not much experienced in the 5G technology. I can answer from the Wi-Fi technology point of view, right? How to reduce the latency, right? Is that something I can relate to Wi-Fi, right? Basically, if you have demanding low latency application like VR, XR handset, okay? So if you have a single channel and if the channel is completely congested, right? You are having multiple clients connected in the medium. So the access point has to schedule packets for all the clients. It's just not one client. It has to identify that, hey, I have a list of clients. I have to do a round robin scheduling, or I want to do a priority scheduling in whatever way it wants to schedule. It has to 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 go how the pipe is congested or kind of free. If the pipe is congested in channel 1, right? Now we have this multi-link connection. It doesn't need to connect back to channel 2, right? It dynamically switches in the low level at a MAC level or at a file level, right? So it can talk to each other and decide, hey, this particular link is too bad, right? I don't get any response. So I cannot use that link for upcoming packets. I have to switch the link back to the channel or the link where I have the free medium so that the complete latency is achieved. That's a simple high level concept that Wi-Fi 7 brings in. Hope I able to explain it in a simple way. But if you want to understand more details, you want to understand the complex architecture of the AP and the star at a lower level. But at an abstract level, we have very low hardware. At a hardware level, we can have synchronization to talk to each other and decide, hey, which link I should take to transmit. Okay, there are protocols that helps us. There are RTS, there are CTS. Basically, in this particular alternating multi-link, basically the AP will send RTS in both the channels because the station is able to receive in both the channels. But it will respond only in one channel. In whichever channel it feels best, it will respond to that. So AP has to switch back once it receives CTS. AP has to switch back that, hey, channel 1 is the one I get the response. So my current data that I have to send, I have to use channel 1 link to send the data. That's how I think this alternating multi-link is achieved. So that way you are indirectly you are achieving the per packet latency. I hope I explained in a very simple way. Yeah.
Okay, sir, but if you talk about any algorithm is there to improve out to latency? Is any?
So we have proprietary algorithms. I think I am talking from with respect to Qualcomm technology, right? Software technology.
Okay.
So, right. So how do you manage let's say you have hundreds of clients in the network, right? So how do you prioritize it? How do you identify what type of traffic it is, right? What is the latency requirements? What is the throughput requirements, right? So we will classify the packet, right, using hardware and algorithms, and we will map the service class. Hey, for this particular packet flow, I need a high kind of a throughput or low latency kind of marking, and the scheduler that is running in the like our target Wi-Fi firmware, right? So they will prioritize more frequently. So when you prioritize more, there are hundreds of clients, but still you are telling that scheduler that, hey, this particular flow is high latency flow or low latency flow or high throughput flow. You mark that flow as very important. Once you tell that information to that scheduler will kind of prioritize that flow, and eventually it reduces latency and increases throughput based on what you are telling the firmware to do. But when to do and those things is all algorithms, right? It's all proprietary algorithms, right? Each and every vendor will do differently, right? There is no, I don't know any open source application that exists to kind of optimize. Probably you can do uh, to some level, but yeah, not completely. All the hooks will not be exposed, right? Yeah.
Okay, sir.
Okay. Okay. In this particular multi-link connection, right? Use the first link to avoid congestion, low latency. I have explained it, right? So I think it should be easy to interpret. So it kind of switches at a per packet level. Okay. That's a kind of animation I've showed you, right? It listens in both the channels, but it responds only in one, so that whichever channel responds, the access point will use that channel to kind of schedule all the packets. That if we go to the next slide. So it is a simultaneous multi-link operation, okay, where we have dual radios or like a tri-band radio, okay, where we have 3 or 4 up to 16 we can have. Spec supports up to 16. Okay, so that means that parallelly, right, you have 16 pipeline to talk to each other between AP and star. So as you build complex hardware, throughput increase. But yeah, mostly to my understanding, they will use 3 links, 2 gig, 5 gig, 6 gig. This is the kind of a like common deployment in the station. Access point will have 4 or 5 links maximum. That's the common deployment today. So beyond that, I have not seen a product in the market, but maybe a special use case product might exist. But yeah, this is the product where we have like a at least minimum 2 to 3 links, right? Or it may connect in 3 links, but active in 2 links, basically. It uses both the links. We have always both links exist, right? That's a kind of a background behind this, right? It uses simultaneously both the links or tri links so that it achieves the high throughput, right? So certain applications require very high throughput, right? Particularly some of the XR kind of a demanding application where the rendering should be pretty high. We need to quickly download a lot of things, right? So this might help. Yeah. Okay. Let me move to the other next slide. Okay. So I'm jumping into another dimension of Wi-Fi 7, how the real world is getting adopted, right? So before talking into that, right, I want to give a perspective of the spectrum availability, right, of Wi-Fi across or varies across the world, right? 2.4 gig, most countries support it, right? 20 megahertz, 40 megahertz, right? I don't see which sub-country limits that. Okay, so 5 gigahertz band, all major regions supports this. It supports 20 megahertz, 40 megahertz, 80 megahertz, 60 megahertz. So far, till 11 AC, this is the maximum bandwidth. So we have these two bands for Wi-Fi, the unlicensed band, right? Where we can use the Wi-Fi. So, but these two bands kinds of interferes with a lot of other Wi-Fi other like wireless technologies. So, okay, sorry. Okay, so now comes the 6 gig band. Okay, 6 gig has opened in few countries, particularly right, US, Canada, South Korea, Brazil, and Europe, Japan, UAE, Australia. This might be expanded now. This might be a little old slide, but what I'm saying is like a lot of countries opening up for 6 gig band for Wi-Fi, unlicensed band. So with all these bandwidths, okay, so we have to deliver and meet all the kind of customer use cases, right? So let me say the 2.4 gig is mainly used for kind of IoT devices, okay, where the 5 gig and 6 gig is used for kind of a maybe high speed to low speed. If you look at this, right, 6 gig, we have, if you want a very high speed, okay, and you have a very good signal range, I think usually the connections or the traffic will go in 6 gig band. All the packets will be scheduled in 6 gig, right? Whereas the 2 gig is reserved mostly for the IoT and other kind of devices where like there is no much traffic, right? So mostly cameras and like where there is no throughput is a requirement. It's just a long range and just a very minimal Wi-Fi connection is required, right? So I think that way it completely avoids the congestion to one WAN, right? So that's where I think the APs are scheduling the packets based on, hey, what type of client it is, whether it is like a high demand throughput client or it's a low latency client, right? Based on that, it will kind of schedule the packets on that particular link, right? Likewise, the client also can do the same thing, right? It's just not AP scheduling, right? So uplink scheduling also can be done that way. That is another dimension, right, to look at, where higher band connections are used for low latency and high throughput, whereas like low band spectrum is used for IoT and Bluetooth. Okay, so if you look at this, right, so in this example, right, so we have this high band simultaneous. So high band simultaneous means like the Meta Glass or this phone, right? So they will connect to the higher band of spectrum, right, and use multi-link operation. Most of the time, this is how it happens. So they require high throughput and as well as low latency. Right, to achieve this, that is how the access point will schedule packets. The clients also will use that way. So they will not even connect to the 2.4 gig because most of the devices, they will have only uh, two files, right? That file will be used to program in the 5G and 6G, not in the 2G. They will not even connect in 2G. They will move to 2G only if the link is too far. Till that point, this will be still in the upper spectrum, right? That's why we call like always like high band simultaneous multi-link. So they will use 5 and 6. They will never use 2 for their connection. They might use 2, but they will never even come to 2 unless they are too far from the access point. So that's the another kind of way to look at this. So I think I come to the summary of the slide. So I want to see if there are any questions on the Wi-Fi 7. So far, the slides I covered. Okay, so let me go to the summary slide. Okay, so what is the summary of Wi-Fi, right? So Wi-Fi 7 summary is right to provide faster connections and consistently kind of try to get the lower latency, right, on the input networks. High band simultaneous multilink designed to support multiple connections for a given client so that it tries to meet all the demanding wide-like experience. Okay, and it has a adaptive medium utilization technologies, right? So to use puncturing and this multi-user OFDMA, right, to kind of effectively pack all the resource units to the client, right? So Wi-Fi 7 has evolved to kind of meet all the demanding kind of use cases in AR, VR, enterprise, metaverse, right? So online gaming, cloud gaming, right? So I think with this, the how the paradigm like Wi-Fi 6 has a lot of limitations to meet all this new user experience, right? So Wi-Fi 7 uplifts with so many kind of hooks to support this user experience, right? So that's the core kind of a technology that has been adapted, right? So I think now a lot of devices has been deployed, and we have kind of seen the user experience has been improved quite a bit. And I have another session that is coming tomorrow, which will talk about some of the pitfalls in Wi-Fi 7, what Wi-Fi 7 cannot meet, and what is the next gen that we have to work on, right? Wi-Fi 8. What are the things that is kind of considered for Wi-Fi 8 technology, right? So probably I will give a overview of that in the tomorrow session. I think I am done with the session. I thought there will be so many questions, but looks like either my session is pretty clear, or probably I didn't give I didn't kind of be simple enough to make
Yes,
some
sir.
of the
Yes.
questions.
Thank you, sir, for your insightful session. And maybe there is any question.
Yeah, there is a question over here. How does Wi-Fi 7 manage interference when many devices use multiple links?
Okay, so let's say I've kind of explained, right? Interference management is I think I brought in this thing, right? We'll go back to this slide. you understand this is pretty right. This is like an interference. Let's say you this is like a 160 megahertz channel. This is a fat pipe. Okay. Let's say this particular subband is having a high interference. Okay. So the Wi-Fi 7, what does it do? The Wi-Fi 7 tells in the preamble that, hey, this particular part of the subband is occupied. Okay. Don't use this for any transmission or filtering on reception, right? You puncture this and use the remaining spectrum. Whereas in Wi-Fi 6, if you want to kind of use, you are completely kind of this particular secondary 180 is unutilized, right? So this is the only difference from Wi-Fi 6 compared to Wi-Fi 7, how it is managing. Other than that, I don't see any additional key technology difference that brings in. So Wi-Fi 7 has a concept of, okay, static functioning, and they have a dynamic functioning. Okay, static functioning is something like, I can go into depth, right? Static function is something like where, hey, that particular subband is completely punctured for the whole like time window. It is detected that, hey, this particular subband is very highly congested. I will not transmit anything for the whole BSS, right? Or the whole rest of the BSS operation, right? The access point will kind of signal that, hey, this particular subbands are punctured. We can puncture multiple subbands also. We can signal that information. There's a puncturing bitmap in the beacon, right? Which tells, hey, what are subbands are punctured, right? With that static information, the client will understand that, hey, whatever the Wi-Fi packets that is transmitted by the access point will have this subbands punctured, so that I don't need to decode that, right? That is static functioning. Dynamic functioning something is not actually uh, um, kind of explicitly called out in specs. Spec has certain limitations, but there are some proprietary algorithms at a per packet level we can puncture. That is called dynamic puncturing. At a preamble, we can signal, hey, which all subbands can be punctured. So I think Wi-Fi 7 brings two core kind of underlying technology to manage this interference, both in a static way, where you know that, hey, that particular subband is occupied by some non-Wi-Fi interference or some OBS interference or any kind of interference, right? As long as you have a way to detect it and you can mark it, then it's pretty good. Even if you don't have a way, you can detect at a per opportunity level, you can do a dynamic function and manage this. I think that's the two core kind of ideas that we can use it for, yeah, interference management. Is that
the next question that has asked this is Wi-Fi 7 backward compatible?
Oh, yes. Okay. Wi-Fi 7.
Yes.
Okay.
Is
Whenever we deploy, yeah,
compatible?
that's yes, yes. The answer to that question is yes. Okay. Wi-Fi 7 is a network deployment where it will allow Wi-Fi 7 clients, right? And it will use 11B MAC. Okay. Let me go back to this. Okay. Okay. So when we deploy a Wi-Fi 7 AP, okay, we should support whatever is supported in Wi-Fi 7, right? All this technology. In addition to that, it should support Wi-Fi 6, Wi-Fi 5, Wi-Fi 4, and even before. All the technologies has to be supported in the product, right? Else, once you deploy a router in your home or in a corporate environment, right? There could be a lot of legacy devices. Wi-Fi 7 is evolving. Still, there are so many legacy devices. Wi-Fi 6 is current trend. If you look at the market trend, right? We have so many Wi-Fi 6 clients in the market. That's a sweet spot. Now 6E is another new technology that comes into the Wi-Fi 6. 6E is like 6 week spectrum. So I see the market is expanding to deploy 6G band technology, right? Or the band spectrum. So to your question, yes, Wi-Fi 7 is backward compatible in all the legacy devices. It has to support 11B Mac and Phi technology. It has to support 11AX Mac and Phi technology. It has to support Mac and Phi AC technology, 11N technology, and 11G technology. It has to support everything. When we say Wi-Fi 7 certified, everything is included. That's a like a
Okay.
full
Then next
yeah.
question that is asked is.
Thank you, sir,
I
for
am
the
a-
clarity. There is one more question.
Two questions are there.
And what terminology is used for V2V या V2X connectivity in terms of routing protocol?
Oh, yes, VR virtual reality, you're saying? Okay, I think so there are multiple generations of product, right? Wi-Fi 6 product. Maybe I kind of take the question that way, right? So maybe for the VR and XR devices, right? What kind of technology is used? I believe Wi-Fi 7 for all the latest VR and XR client devices. I think we will have 11B connection, multi-link connection. I think there could be some older generations that might have 11AX connections, but that may not be able to meet all the use case requirements of like latency and throughput in a congested environment. If the congestion is not there, if there are only very few clients, I think still you can meet all the requirements of this devices. But when you have large number of clients, when you look at a typical US home in US, there are hundreds of client devices, right? We have every home at least minimum 50, 60 Wi-Fi devices, IP addresses, all are Wi-Fi, right? Like laptops, mobiles, and like every device you take, there's a Wi-Fi, right? So we have to categorize that and manage it effectively. So I think I can I think you should refer to the company website. So my understanding with the product view is they will have Wi-Fi 6, which is the initial version of the VR/XR devices. But I think recent versions of devices will have Wi-Fi 7 client technology. Yeah.
One more question has been asked by Mr. Ravi Kumar R. I am working in Wi-Fi based sensing. Is there any feature that support continuous data that is required to sense the CSA of the environment?
Okay, so I think for sensing, I think there is a separate Wi-Fi standard, basically. So Wi-Fi 7, I don't have full kind of a recap on that, but there are certain advancement that has been brought into sensing, right? The latest version of the sensing specification, right, which helps to kind of capture like mostly the location kind of a precision, right, has been improved drastically. Basically, 11AZ technology for Wi-Fi based sensing. Okay, but if you want more details, I can refer to some of the slides. But I don't have the